Hello, this is Miss Worsham. Back to you with some more math. We're going to have fun today because we're going to be multiplying using area models. And we are going to be looking at the partial products and the standard algorithm. And we're going to see how that can kind of flow together and compare those. So let's get started. Okay, solve these problems by using an area model. And this is just kind of a review for you guys. We've been working with area models and multiplication. Remember, product means the answer when you multiply. So that's what we're going to be finding today. We're going to be finding the product. All right, let's go in. Let's draw our area models. Okay. I'm going to have 24 here. And remember, when we look at area models and partial product, partial means part. And remember, product is what we will be finding, and that is the answer when you multiply. Okay, so I am going to break this in half, okay, horizontally. And I'm going to take the value of the 15. I have 110 and I have 5 ones. 10 times 24, that's going to be 240. And then 24 times 5, I'm going to do my math here at the side. And I have 120. When I add these or find the sum, remember sum is the answer. When you add, we have to get used to that math terminology. We have 0 here. 4 plus 2 is 6. I have 360. Now I'm going to work this out using traditional algorithm. I have 24 times 15. 5 times 4 is 20. 5 times 2 is 10. Plus 2 is 12. I'm going to write my 0 here because I'm finished with my ones place and now I'm going to my tens place. 1 times 4 is 4. 2 times 1 is 2. And this gives me a product of 360. So these products are equivalent here. This one I worked out in an area model, and this one was traditional algorithm. I want you to look at my partial products here. Look how they're lining up. Okay, compare those and look how they are equivalent, whether I am working it out by an area model or whether I'm using traditional algorithm. Okay, then we have 824 times 15. So I'm going to go and erase this. So I have a 3-digit number this time multiplied by a 2-digit number. So I have 824 times 15. And we can go ahead and start with traditional algorithm. I have 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. I have 8 times 5 is 40, plus 1 is 41. I'm going to write a 0 here. I'm finished with my ones. I'm going to my tens. 1 times 4 is 4. 2 times 1 is 2. 8 times 1 is 8. And I'm going to go in and I'm adding these. And I have 12,360. Now I'm going to draw my area model. And I'm going to just put the number 824 up here. And I'm going to break this in half like I did before, horizontally into 2 sections. I'm multiplying times 15, so I have 110 and I have 5 ones. And I know that 824 times 1 is 824. That 0 represents I got to multiply that by 10. So when I multiply 824 times 10, I get 8,240. And then when I multiply 824 times 5, I'm going to work that out to the side here. And I have 4,120. Look how these partial products are lining up, guys. Look. Okay? And hopefully I'm going to get the same product when I find the sum. Remember, sum is the answer when you add. So I have 6, 3, I have 12,360. Look at those products. They are equivalent. Okay, let's look at the application problem. Remember, when we are solving word problems, we are following a model. And that model is RDWW. I need to read the problem at least twice. I need to draw the problem out. It may be a tape diagram. It may be an area model. It may just be our thinking. And then I'm going to write an equation, and then I'm going to write to explain. And you guys might say, write to explain? Yes, we're going to use words and math. Okay, let's read the problem. The length of a school bus is 12 6/10 meters. If 9 school buses park end to end with 2 meters between each one, what's the total length from the front of the first bus to the end of the last bus? Okay, this is a problem where we're going to really have to draw this out, okay? We have to pull out the factual information here. And the factual information is 12 6/10 meters. That's the length of a school bus. And then the school buses park end to end with 2 meters between each one. What's the total length from the front of the first bus to the end of the last bus? Okay, so we have a length, and we know that we have, if 9 school buses park end to end, I forgot to underline that. So we have 9 school buses. And I know that the length of one school bus is going to be 12 6/10. So I'm going to draw out 9 school buses. And I know that each one of these school buses is 12 6/10. That's what they measure. Okay. And then what other information do we have here? School buses park end to end with 2 meters between each one. Each one. So between each one of these, it's going to be 2 meters. So I'm going to put 2 meters between each one of those. Okay? So it says, what's the total length from the front of the first bus to the end of the last bus? What is our equation going to look like? If we was to draw a tape diagram, what would it look like? Well, if I'm drawing a tape diagram, do I know my total? That's the first question you need to ask. And no, I don't have my total here. That is my unknown. That's what I'm trying to find out. And yes, I can draw 9 spaces. And I can put 12 6/10 in each one, just like I did here. I can also put in my tape diagram a little line down here representing 2 meters in between each bus. So, what is my equation going to look like? Well, it's going to be 12 6/10 times 9 equals x. Remember, x represents my unknown. And then x, and then I'm going to have to add 2, okay? Or how could I really write this into an equation? Could I put parentheses around this and add 2? I could do that. So let's go in and let's multiply 12 6/10 times 9. And if I do that, I'm going to have, let me erase this. I'm going to have 12 and 6/10. Erase that really good. I'm going to have 12 and 6/10, which I'm gonna go in and write all whole numbers because I love dealing with whole numbers instead of decimals. And then I'm going to write my unit out here, 126/10 times 9. And then I'm going to convert my unit form, which is tenths, okay, in my product. Remember, product is the answer when you multiply. So 9 times 6 is 54, carry my 5. 9 times 2 is 18, 19, 20, 21, 22, 23, carry my 2. 9 times 1 is 9, plus 2 is 11. So I have 1,134. Now I need to place my decimal into my product. How can I show this or represent it as tenths? Okay, I'm going to have 113 and 4/10. Now I need to add my 2 meters between each one. So I'm going to have 2, 4, 6, 8, 10, 12. Is that right? If I have 9 school buses, I'm going to have 2, 4, 6, 8, 10, 12. So that would be 13. That would be 16 in between. So I'm going to go in and I'm going to add 113 and 4/10. And I'm going to add 2, 4, 6, 8, 10, 12, 14, 16. And I can fill in with a 0 there. And I have 6 plus 3, and I know that's going to be 9. And then I have 1 plus 1 is 2, and then I have 1. So 129 and 4/10. 129 and 4/10. Now I can go in and I can answer my question. What is the total length from the front of the first bus to the end of the last? 129 and 4/10 meters. Notice I drew the problem out. I came up with an equation, okay, to solve for x, my unknown, and then I came up with a product here. Okay, good job with that. Okay, 524 times 136. Compare this problem with the problems the previous lesson. What do you notice? Okay, with this problem, I'm noticing that I have a 3-digit multiplied by a 3-digit number. So that's a little different because I have hundreds multiplied by hundreds. But we can still do it. And we can still draw our area model and use our traditional algorithm. Okay, so we have 524 times 136. Okay, I'm finding my product here. Okay, I'm going to go in and draw an area model. I'm dealing with bigger numbers here. So I want to really decompose my numbers well into my partial product or area model. So I'm going to go in, I'm going to draw a big area model, and I'm going to break it in 3 parts, vertically and horizontally. So I'm going to take the value of the first number. So I have 5 hundreds. I have 2 tens, which is 20. I have 4 ones, which is 4. Here I have 100. I have 3 tens, which is 30. I have 6 ones, which is 6. Okay, this is just like saying 5 times 1 and 100 times 100. Okay, so I'm going to do 5 times 1 is 5. And I know 100 times 100 is going to be 10,000. So I'm going to add those 4 zeros there, and I have 50,000. Now 2 times 1 is 2, and this is just like saying 100 times 10, and I know that's 1,000, so I'm going to have 2,000. Now I have 100 times 4. That's going to give me 400. And then I have 30 times 500. I know that 5 times 3 is 15, and this is just like saying 100 times 10, and I know that 100 times 10 is going to equal 1,000. So I have 15,000 there. 3 times 2 is 6. This is just like saying 10 times 10. We know that 10 tens make 100. So let's go in and multiply. We have 600. 30 times 4, that's just like saying 4 times 3 is 12. And I'm going to multiply it by 10. And I know that 12 tens equals 120. Now I have 6 times 5 is 30. And I know that represents 100, those 2 zeros. So I'm going to go in and add 2 zeros. 6 times 2 is 12. And then this represents times 10. And I know that 12 tens equals 120. And then we have 4 times 6, and we know that that is 24. So I'm going to go in and I'm going to add these. I have 50,000. 15,000 and 3,000. So I have 7, 8, and 6. And you guys let me know if I'm doing something wrong. Now I'm going to add 2,000 plus 600 plus 120. So that's going to give me 2,700. And then I have 400 plus 120 plus 24. That's going to give me 544. Now I'm going to take my products here and I'm going to find the sum. Remember, sum is the answer when you add. I have 68,000. I have 2,720. I have 544. I'm going to go in and I'm going to fill in with zeros because it just makes the problem look a little bit better. So I have 4, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I have 11 here, 7. So I have 71,264. Let's go in and let's multiply traditionally. Let's see how these partial products line up to what we're doing here. Okay? All right, here, I hope you guys can see me. Let me move it over a little. Okay, I have 6 times 4, and I know that's 24. Carry my 2. 6 times 2 is 12, plus 2 is 14. 6 times 5 is 30, plus 1 is 31. I'm going to write my 0 here. I'm finished with my 1s. Now I'm going to my 10s. 3 times 4 is 12. I'm going to mark that out. Carry my 1. 3 times 2 is 6, plus 1 is 7. And 5 times 3 is 15. And now I'm going to write 2 zeros. I'm now finished with my 1s and my 10s. Now I'm going to my hundreds. I have 1 times 4 is 4. 1 times 2 is 2. 5 times 1 is 5. And I'm going to add 4 plus 2 is 6. I have 12 here. 5, 6, 7, 8, 9, 10, 11. And then 5, 6, 7. I have 71,264. Look at my products. Look how they're matching up, guys. See that? Also, look at this, how this is matching up. I have 2,400. And it would match up if you add these together, okay? That the partial products would match up that way. But guys, we can solve multiplication problems by first using this area model, okay? And then going in and solving traditional algorithm and comparing our products. Remember, product is the answer when you multiply. Okay, so the only difference between the problem we just did and this problem is now we have thousands and we're multiplying by hundreds. So I'm going to go in and set up my problem, and I'm going to set it up for traditional algorithm, and then I'm going to draw my area model. I'm going to have a big area model here. Okay, I hope you guys can see that. Okay, I'm going to break this down or decompose it by its values. Remember, value is what it's worth, the place that it's in and what it's worth. I'm breaking this into 4 sections. I'm breaking this into 3 sections horizontally. I'm taking the 4, and I know that that 4 is in the thousands place. So I'm going to write 4,000. The 5 is in the hundreds place. I'm writing 500. The 1 is in the tens place. I'm writing 10. And then I just have 9 ones here. Now I have 326. Okay. All right. I know that 4 times 3 is 12. And I know that I'm going to be multiplying 1,000 times 100. And I know that that's going to give me 100,000s without even looking at it. So I'm going to go in and say 4 times 3 is 12. And I'm going to just write my zeros. I have 1, 2, 3, 4, 5. So I have 1,200,000. Now I have 100 times 100. And I know that's going to give me 10,000. So I know that 5 times 3 is going to be 15. And that's going to be 150,000. Now I have 3 times 1 is 3, and 100 times 10, you should know that's 1,000. So I'm going to have 3,000 here. 9 times 3 is 27, and I have 100, so it's just going to be 2 zeros there. Then I have 20 times 4,000. 4 times 2 is 8, and I know that 10 times 1,000, that's going to be 10,000. So I'm going to have 80,000. Now I have 5 times 2 is 10, and I have 1,000 because 10 times 100 is 1,000. Now I have 10 times 20, and I know that 2 times 1 is 2, and I'm going to have hundreds there. Now I have 9 times 2 is 18, times 10, I have to add 1 0. 6 times 4 is 24,000. Okay, 3 zeros there. 6 times 5 is 30, and I'm going to add 2 zeros there. 10 times 6 is 60. 9 times 6 is 54. Now I'm going to go in, I'm going to add all my partials. Let's see what I have here. I have 1, 2, 3, and then I have 4,000, and then I have 8, 9, 10, so that's going to roll over to this. I have 3 here, and then I have 1 here. So that's going to be 1,304,000. Okay, here I have 150,000 plus 10,000 plus 3,000. So I know I'm going to keep that 3 here, and I'm going to have 6, and then I'm going to have 1. So let's kind of split that up. I'm going to have 163,000 there. I'm going to have 3,260 here, and here I'm going to have 4, 5, and actually I'm not going to have 5. Let's see. I'm going to have 4. I'm going to have 13 here. Carry my 1. And then I'm going to have 7, 8, 9. And I hope I did that correctly. Now I need to go in and find my sum. sum is the answer when you add. So I'm going to go in and add all of these. Let me double check this to make sure I have this correct. Yes, I do. Okay, let's go in and let's add all of our products. So I have 1,304,000. I have 163,000. I have 3,260. I have 2,934. And I'm going to go in and fill in with zeros because that makes me a little more comfortable. I have 4 here, 9 here, 11. Then I have 4 plus 1 is 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I have 7, 4, 1. So I have 1,473,194. See, hope you guys see that. I'm going to put my product, my final product right here. And those were some big numbers that I was dealing with. So I'm going to go in and I'm going to work it out traditionally and make sure that I have the correct product. Because if I don't, I'm going to have to rework. And that's what we have to do sometimes. All right, so we have 9 times 6. I know that is 54. Carry my 5. 6 times 1 is 6. This is 11. 6 times 5 is 30. Plus 1 is 31. 6 times 4 is 24. 25, 26, 27. And then I'm going to write a 0. I'm finished with the 1s. 9 times 2 is 18. And I'm going to carry my 1 up here. I have 2 times 1 is 2. Plus 1 is 3. 5 times 2 is 10. Carry my 1. 4 times 2 is 8. Plus 1 is 9. And then I'm going to have 2 zeros here. And then I have 9 times 3. And that's going to be 27. 3 times 1 is 3. Plus 2 is 5. And then 5 times 3 is 15. I'm going to carry my 1. And then 4 times 3 is 12. Plus 1 is 13. I have 4, 9, 7, 8, 9, 10, 11. I have 7, 8, plus 5 is 12. I have 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 4, I have 1. Whoop. I'm off, guys. I have 1,472. 7, 8, 9, 10, 11, 12. Forgot to add my 1 up here, so that should be 3. Woo! Thought we were off a little bit. Okay? All right, so 1,473,000. That should be 194. Okay? All right, we have our product here. Using traditional algorithm. We have our product here using an area model. Guys, it's real important you know your multiplication. It's real important that you use your distributive property in multiplying with the area model. Okay, I hope you guys enjoyed this lesson and I hope it was beneficial. See you next time.